Hello, our lovely viewers. Welcome again on board. With our program is still on, our course is still on, helping our learners to go through the 2021 KCSE Mathematics Paper 2, like they requested us. So with our number 15, what a question. The question reads, the position vectors of points P, Q, and R are 1, -1, 3, 3, 3, 1, and 6, 9, -2, respectively. Show that P, Q, and R are collinear. So, collinearity of points we did already, and we posted our question. So this is just going to be part of revision to many of us. So to my learners again and viewers at large, what we said, remember, when we have 3 points and we want to prove whether they are collinear, there are only two aspects here we are going to satisfy. Number one, they should have a common point. That one will depend on our choice of points. It doesn't matter. Number two, we should have what we call one vector should be a scalar quantity of the other. Scalar quantity of the other, or a scalar vector of the other. So if they satisfy the two, then we shall conclude that the 3 points are on a straight line. We call it are collinear. So I've done it. I'm just going to help you go through it. I've picked my points, taking notes. Like I always say, my teacher used to say, take notes. P is given there 1, -1, 3. Q 3, 3, 1, and R 6, 9, -2. Then I've chosen 2 points, PQ, at random. I want to get the column vector of PQ. So PQ means position vectors of Q minus those of P. And therefore 3, 3, 1 minus 1, -1, 3. We shall be able to get, so we know how to minus vectors. That is first element for first element, and therefore 3 minus 1 is a 2, 3 minus minus is a plus. So 3 plus 1 will be 4. And lastly, 1 minus 3 is a minus 2. So the column vector representing PQ is 2, 4, -2. So I choose again points of my own choice. I've chosen QR now. How do we get QR? Just like we have done PQ is now the position vectors of R minus those of P. Of Q. And therefore, 6, 9, -2 minus 3, 3, 1. We shall be able to get 6 minus 3 is a 3. 9 minus 3 is a 6. And finally, minus 2 minus 1 is a minus total of 3. So, now we have the 2 column vectors. We want to verify whether one can be a scalar vector of the other. So this is the law here. What does it mean? It means when I take PQ, it should be equivalent to a certain K, which represents scalar here, scalar by QR. So to do this, I'm just going to consider individual elements, that is 2 and 3, the upper elements. So 2 should be equivalent to 3 times K. So dividing by 3 on both sides, I'm finding my K should be 2 over 3. So the same law should apply to all the elements. Let's prove again with the second element, that is 4, 6, and K. So 4 should also be equivalent to 6K. Dividing by 6, K we are finding is still the same. And you can lastly prove it with the last element, that is -2 should also be equal to -3K. Dividing by -3, the minuses shall cancel, and we shall still remain with 2 over 3. So therefore we can rewrite everything as PQ, therefore should be equivalent to K now, which is 2 over 3 QR, and that law is already satisfied. And do they have common points? We said we have two laws here. Do they have a common point? And the common point, according to our own choice, was PQ and QR. So our common point is Q for that matter. So they have a common point, Q. So what do we say? We therefore conclude that point P, Q, and R are collinear. They are collinear because the two laws have been satisfied. One is a scalar vector of the other, and they have a common point Q. Thank you guys. Follow this keenly. Use this concept to do 2-3 more questions. And like I said, let me assure my learners, you can never miss a question on vectors in KCSE. So practice, use this to practice. There's another question we did already under projections 2023 under vectors where we were able to get the constants. So please study through, follow us keenly, use the concepts, put them on practice. Do 1, do 2, do 3. Then you become a master. So thank you guys. Subscribe, share knowledge, and let's like. Be blessed. Thank you.